Okay, so this is going to be for the practice quarterfinal. This is question 3 in the applications. We have world population. Here's kind of how it works though. There is like a time in 1990 where it says it's 5.3 billion. Sure. Then we have the annual increase because clearly it's a population, so we know it's going to be increasing by 4%. We have 3 different parts. Find the function, find what happens in 2030, and then the years or how much time has passed for 10 billion. I think it helps us to obviously underline this. So clearly I have to start off with 5.3 billion. Then I have to underline 4%. Now, because of these different facts, I have to ask myself, well, what is this function? This function and the whole essence of this is what we call an exponential, right? So if I had to write an exponential function, what would that look like? There were 3 that we discussed in class. There is PERT, which is the continuous function, p times 1 plus r over n, that's compound, and then this one, which is going to be the regular one. For any exponential equation, we usually like using this one, a times 1 plus r to the power of t. So if I'm going to write a function, I have to clearly establish what some of them are. A is the starting amount, which I can see is 5.3 billion. So I'm going to finally put that here. So a is going to be 5.3. Well, clearly, then I have to look at the next part, which is 1 plus r. So I'm going to put in parentheses 1 plus, and what is r? Well, r is going to be my percent, but I'm going to make it into a decimal. How do you make it into a decimal? I like to think of it as taking 4 divided by 100, which we get 0.04. So I'm going to put that here. 1 plus 0.04. And the last part, time. Do I know time yet? Not quite, because I don't know how much time has passed. So I'm just going to put it as t. Technically, if you want to be a little bit simpler, you can add these 2 on the inside, giving you 5.3 parentheses 1.04 to the power of t. Okay, that's cool. So I think I can use this equation for part B. It's asking us in 2030. Now, a lot of mistakes can happen here. You can think to yourself, oh, I see a time, 2030. Why not plug it in? I don't know t. Well, that's good idea initially, but the problem is the question clearly states in 1990. There's time from 1990 to 2030. You have to take the difference between the two, and so one thing I like to do is I like to do 2030 minus 1990. Once I'm able to do that, I can subtract it and see how much time has passed. That gives me an answer of 40 years. Okay, cool. I can use this new time to plug it in for t. So that's what I'm going to do. I'm going to put 5.3 parentheses 1.04 to the power of 40. I'm going to put that in my calculator, and the way I write that is I put 5.3 parentheses 1.04 to the power of 40. This gives me my answer of 25 billion 0.45, and I gotta write billion. Okay, so that's cool. We now move on to part C. Part C is asking us how many years it will take to reach 10 billion. What equation am I going to use? Again, everything revolves around part A. Part A, if you don't get, you kind of don't know how to do the rest. And so in this equation, what we're going to do is that we're going to use the equation 5.3. So I'm going to write it right here, 5.3 parentheses 1 plus 0.4 to the power of t, and it has to equal to 10 billion. So I'm going to make it equal to 10. You might be asking, well, how do I solve this? Simple. You have to get rid of this 5.3. It's blocking my way. I divide both sides by 5.3 and see what I get from there. 5.3's cancel out, leaving me with 1.04 to the power of t equals, and I'm just going to use my calculator, 10 divided by 5.3. That gives me 1.89. Now, what do I do from there? I have this exponent, I don't like it, so what am I supposed to do? To undo the exponent, you're going to take the logarithm or log of both sides. So I'm going to write here log 1.04 to the power of t equals log 1.89. Now, what does that benefit us? This power of t, because it's a logarithm, has this thing called power rule. Power rule allows us to move the t to the front. So that would be t times log 1.04 equals log 1.89. So my last and final step is, well, I want to get rid of this log 1.04. So what do I need to do? I'm going to divide both sides by that. So I'm going to divide both sides by 1.04. And so I'm going to put that in my equation. In my calculator, I'm going to put log 1.89 divided by log 1.04. This gives me my final answer of 16.23 years. And so that's our final answer. So if you're looking at these different parts, we can see here that this is kind of a long one. But the whole point of this is to explain how exponential growth works. You have the regular equation, and in parts A, B, and C, it asks you different things. Part A is asking you how to recognize ART. Part B recognizes how much years have passed by plugging it in. Part C is solving the exponential by simply taking the log of both sides. And that is the end of this problem. It's a complicated one, but I believe you all can do it.